In today's video, we're going to talk about volume and surface area of cylinders. This is still part of our 3D geometry unit, and that color is still yellow. Alright, so the first thing we're going to talk about is volume of cylinders. So we want to consider a single lifesaver. We want to think about what its shape is. Well, that's a circle. We learned that a long time ago. The radius of a lifesaver is approximately 1.5 centimeters. And again, the radius is the distance from the center to the outside edge. So that's approximately 1.5 centimeters. Okay, what is its area? And we're not going to worry about the hole in the middle there. We're just going to find the area of the entire circle. So our formula for area of a circle is pi r squared. So we're going to plug in 3.14. The radius is 1.5, and that's squared. So for order of operations, the first thing we would do is square 1.5 and then plug in 3.14. And if we do that, we should end up with 7.065 centimeters squared. Okay. So again, you would do 1.5 squared times 3.14 to make sure that you're following correct order of operations. And now we're going to consider a roll of lifesavers. This is like a three-dimensional circle. We have a circular base here, and then it has a definite height. So this shape would be a cylinder. Okay, the height of the roll of lifesavers is approximately, and we're going to change that 2 inches to 5.1 centimeters because we don't want to mix units. Okay, so I know that the length of, or the height of this cylinder is 5.1 centimeters. Always a good idea to label your drawing. Using this, along with what we know about the area of one lifesaver, how could we find the volume of the stack? Well, if we know that the base of our cylinder, this part right here, this circular base, has an area of 7.065 centimeters squared. That's just one piece of it. And then there's a height now associated with that circle. So what we can do is we can take the area of that base and we can multiply it by the height, and that's how we get the volume of the stack of lifesavers. So the area of the base was 7.065 centimeters squared, and then the height was 5.1 centimeters. So when we multiply those two numbers together, you should get 36.03 centimeters cubed. Give you extra blank there that you don't really need. Okay. So the formula for the volume of a cylinder is the area of the base, the area of that circle, times the height of the cylinder. But we know that the formula for area of a circle is pi r squared, so we can fill that in instead of a, pi r squared, times the height of the cylinder, so pi r squared times h. Okay, two examples here. We have one cylinder that's laying on its side here. We're trying to find the volume, so we're still going to use pi r squared h. So the volume is going to be 3.14. Radius is on the side because our cylinder has been tipped over. So our radius is 4 squared, and our height is 10. And that 10 is along the bottom. All right? So the first thing I'm going to do is I'm going to square the 4 to make sure I do correct order of operations. Exponents are first. So I have 3.14 times 16 times 10. And when I multiply all those numbers together in the calculator, I will end up with 502.4 inches cubed. Again, you've got to remember you have to square the 4 before you do that multiplication step. Very important. Okay, example 2, volume is pi r squared times height, still the same formula. So we're going to plug in pi is 3.14. In this example, I'm given the diameter. My diameter is 6. So in order to find my radius, I have to divide the diameter by 2. So my radius is going to be 3 meters. Be careful for that. They love to put those on tests where you have to remember that additional step of dividing the diameter by 2. So my radius is 3, and my height is 18 meters. Again, I have to follow order of operations. 3 needs to be squared. So I have volume is equal to 3.14 times 9 times 18. And I multiply all those guys together, and I get 3.14. Oops, sorry, I already did that part. I get 508.68 meters cubed for my final answer. Remember, volume is measured in units cubed. And then when we go on to surface area here in about a second, you'll remember that that's going to be measured in units squared. Alright, so we're going to turn over to the surface area of cylinders, and we're going to look at these notes next. So again, still part of our 3D geometry unit, and our color there is still yellow. Alright, so the next thing we're going to do is we're going to consider a tube of wrapping paper. And I have a roll of paper towels here, so that's going to be my substitute for wrapping paper. Zoom out a little bit. Okay, if I consider that tube of wrapping paper or toilet paper towels, when you look at its shape, and it's a cylinder. Still a 3D circle, right? Circular base, there it is. Okay, curved edges here. Okay, so if we look at the ends of the tube, how many ends are there? Well, we've got one end here, one end here. That's two ends, two flat faces, and are they congruent? Does this end look exactly the same as this end? And the answer would be yes, they are exactly the same. And if I look at what shape is that, that is a circle. Alright, how can we find the area of both circles? Well, we're going to actually change this. How can we find the area of the circle? And we know that the area of a circle is the formula pi r squared. We get that straight off of our formula sheet. Alright, so if I want to find the area of one end of this roll of paper towels or wrapping paper, I'm going to have to use pi r squared to calculate that. So I'm going to kind of come over here to the side where I have a little bit more space. Area is equal to pi r squared. My radius is 3, so area is equal to 3.14 times 3 squared. Order of operations, have to square that 3 first. So I have 3.14 times 9. And if I multiply those together, I should get 28.26. So my area of one circle is 28.26 inches squared. I'm going to fill that in, 28.26. Now that only takes care of one of the circular ends. But notice we said that there were two. So in order to find the area of both circles, we're going to have to take that 28.26 and we're going to have to multiply it by 2. And so the area of both of the circles would be 56.52. We're going to circle that number because we're going to come back to it. That's the area of both circular bases. So we're going to again take 28.26 and we're going to multiply that by 2. And that gives us 56.52. Kind of jot that note down over here on the side. Okay? So now we're going to think about, as we unroll the tube of wrapping paper or toilet paper or paper towels, what shape does it make? So I'm starting with this cylinder, and as I unroll it, you'll see that you start to form a rectangle. It'll be a little clearer if this were cut smooth, but again, you can kind of see where we're starting to form that rectangle. So as we unroll the tube of wrapping paper or paper towels or whatever we have on hand, we start to make a rectangle. Alright, so we know that the formula for the area of a rectangle is length times width. Well, the width of the rectangle, as I unroll it right here, that's going to be my width. So if I unroll this, my width of my rectangle, zoom out. Here is the width of my rectangle. It goes from here to here. That's the width. Notice that that width is the exact same measurement as the height of my cylinder. Okay? So you can see how the width of this rectangle, as it starts to unroll here, is the same measurement as the height of my cylinder. Fill that bit in. All right, the length of the rectangle is the same as the distance around the circle. So if I think about, as I unroll this, if I unroll it one rotation completely, this distance here is the same as the distance around the circle of my cylinder, or the circumference of my cylinder. So as I unroll it, right, the distance, the length of my rectangle is the same as the circumference of my cylinder. Okay? so the formula that we're going to use for the circumference we know is 2 pi r. Okay, so we want to make sure that we're going to calculate the circumference of that circle so we can get the length of our rectangle. So that's going to be 2 times 3.14, and the radius of our toilet paper, wrapping paper tube here is 3. So the circumference would be 2 times 3.14 times 3, 2 times 3.14 times 3 gives me 18.84 centimeters, inches. Alright? So my area then is length times width, or the height, times the circumference. So the height, right, which is the same as the length, or the width. That height right here is the same as the width. So I'm going to multiply the height, which is 24, by the circumference, which is 18.84. And my circumference is equal to 452.16. Okay, so that's the area of the rectangle piece. Again, length times width. Remember, height was the same as the width, and the circumference was the same as the length. So it's really the same formula. We're just kind of renaming the pieces. All right, so how can we find the total surface area of the tube of wrapping paper? Well, total means add. So we're going to have to add the areas of the circles, which we found up here, to the area of the rectangle that we found right here. So we're going to take 56.52 and we're going to add 452.16. And we end up with 508.68, and this is surface area, so it's going to be inches squared as our final answer. So then we can use this picture here to help us figure out the formula for the surface area of a cylinder. So the surface area of the cylinder is the area of the two circular bases, the one on the top and the one on the bottom. So the area of this piece plus this piece, that's your two circles, so the area of the circles, plus the area of the rectangle that you get when you unroll your cylinder. And we know from our little exploration up here, let's see if I can get a different color, show you the rectangle one more time. That's the rectangle that we get right here from unrolling that cylinder. So the surface area for the area of the circles, that's going to be 2 circles times the formula of a circle, 2 pi r squared, times the area of the rectangle, which was the same as the height or the circumference, 2 pi r, times the height of the cylinder. So again, this is the part from the circles, and this is the part from the rectangle. Although it's not very important if you're just doing straight calculations for surface area, it does become much more important when you start decomposing some of the word problems that we're going to do together in class. Alright, so we're going to just calculate really quickly the surface area for these two cylinders. So I have surface area is equal to 2 pi r squared plus 2 pi r h. So surface area is 2, pi is 3.14, radius is 4, plus 2 times 3.14, radius is 4, height is across the bottom, that's 10. Okay, and I forgot my squared here. First thing we're going to do is we're going to square that. So we have 2 times 3.14 times 16, plus 2 times 3.14 times 4 times 10. So 2 times 3.1, try that again. 2 times 3.14 times 16 gives me 100.48, plus 2 times 3.14 times 4 times 10 gives me 251.2. And then if I add both of those together, I get a final surface area of 351.68. And this is going to be measured in inches squared per area. All right, last example for today, we have one more cylinder we're going to calculate the surface area of. It's 2 pi r squared plus 2 pi r h. So surface area is equal to 2 times 3.14. Remember, my radius for this cylinder is 3, diameter is 6, radius is 3, have to take half of the diameter, plus 2 times 3.14 times 3 times the height of 18. Okay. First part is the square, so we have 2 times 3.14 times 9 plus 2 times 3.14 times 3 times 18. Okay, multiply together that first chunk, and I end up with 56.52, plus multiply together there for the second chunk, and I get 339.12. Again, multiply those, can't hurt to take an extra step here, and that gives me a final surface area of 395.64 and meters squared, since we're talking area.